Hello students, welcome to this lecture number 6 on thermodynamics. In this lecture, we will be going to discuss the types of enthalpies. As you know already that there are various types of reactions and process, and every type of reaction and process will involve the exchange of the heat. Means in the some reaction the heat will be evolved, in the some reaction heat will be absorbed by the system. So there is always a change of enthalpies, and the name of the enthalpies will vary depending on the process or reactions. As for example, suppose we are carrying out some reactions, at that time the change of enthalpy we will call the reaction enthalpy. When the reaction is relating to the combustion, it will be the enthalpy of combustion. When there is a neutralization process, acid base is neutralized, at that time it will be the enthalpy of neutralizations. So in this lecture we will concentrate on those type of enthalpies, and also we will understand some related numericals that will be probable, that will be most probable in coming in the exams. Okay, so today's heading of this video is type of enthalpies. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. So let us understand different types of enthalpies. First enthalpy that we are going to discuss, that is the reaction enthalpy. And every enthalpy is denoted by delta H, that is the enthalpy change, and here you have to write the specific name of the reaction, that is in this case we are totally taken the reaction enthalpy, so we will be put in the small r later. This is the symbol of this reaction enthalpy, and another symbol we will be acquainted, that will be the enthalpy, standard enthalpy. In case of standard enthalpy we have to put some zero value. So zero value here, this is tell the standard enthalpy. So we will first, that is we will discuss the reaction enthalpy, then we will discuss the first that we are going to discuss, that is the reaction enthalpy, and it is denoted by delta H and small r. What is reaction enthalpy? Let us understand. Reaction enthalpy is the heat evolved or heat absorbed and heat absorbed when the number of moles that is going to be reacted, that is going to be represented in a chemical equation, and which is completely reacted with each other, we will call that is the reaction enthalpy, and this is represented by this. So heat evolved or heat absorbed, when we can write, this is the reaction enthalpy. Heat evolved or heat absorbed when number of moles as presented in the chemical equation completely reacted. This is called the reaction enthalpy. And in this reaction enthalpy, what will be there? Now there will be the heat evolved or heat absorbed when the number of moles as presented in the chemical equation completely reacted. When this reactant and its product are in the standard state, then we will call is the standard reaction enthalpy, and that is represented by this. So you understand what is standard enthalpy? Standard reaction enthalpy is this, when reactant and products will be in the standard state. And now what is standard state? Let us understand. Standard state are, there is two things that we have to understand, that is pressure. What is the pressure in this reactant and the product has been kept? That will be 1 bar. And the temperature, that will be 25 degrees Celsius, and in the room temperature it is 298 Kelvin. This is 298 Kelvin. And the reactants and products will be in its normal physical state. So at that time we will call it is in a standard state. When the reactant and products are in the standard state, we will call it the standard reaction enthalpy. Okay. Now there are different types of enthalpy that we have already noted. First the reaction enthalpy, then we will discuss the combustion enthalpy, then enthalpy of formation, enthalpy of utilization, enthalpy of solvation. All this we will discuss gradually. Now what are the factors? There are different factors that will going to influence the reaction enthalpy that we are going to discuss. Factors which influence the reaction enthalpy. First factor is the physical state. Physical state of reactant and products. This is the equation, reaction equation, that from this we can able to understand how this physical state of reactant and product going to influence the enthalpy. From this reaction you can easily understand that physical state of the reactant and product definitely going to influence the enthalpy of the reaction. You can see when the hydrogen gas and oxygen gas combined with each other, it will produce the hydrogen gas in the hydrogen H2O in the vapor state. Its enthalpy of reaction will be minus 241 kilojoule per mole, whereas when it is at a liquid form, it will going to produce this minus 285.5 kilojoule per mole, means the enthalpy has increased. Enthalpy of the reaction has been increased. So physical state of the reaction is reactant and product going to influence. Number one. Number two, the allotropic modification. Allotropic modification. Allotropic modification, we know there are some elements which present in the nature as different allotropes. Right? Carbon present in your diamond, it is present in the graphite rock. So this allotropic modification, suppose diamond is going to react with oxygen and it will going to produce CO2, and in this case reaction enthalpy will be 395.5 kilojoule per mole, whereas this is diamond. When carbon plus oxygen, it is graphite, it will have the different reaction enthalpy, that is 393.3 kilojoule per mole. So allotropic modification also going to influence the enthalpy of the reactions. There are other factors also that is going to be influence this reaction enthalpy, like the nature of the reaction. If the reaction is reverse, suppose it is a reversible reaction and reaction is reversed, then the enthalpy change will be totally different. If it is a endothermic, then it will become exothermic. If it is a exothermic, in the forward reaction it will become the endothermic. As per example, this will be called the nature of reaction. Nature of reaction. Suppose this is a reaction. (91.5 kilojoule per mole). When this reaction is reversed, suppose this, what is going to happen? The enthalpy of the reaction also, its sign will change. Sign will change, will like this, plus. This will be plus. So this is also a factor which is going to influence the reaction enthalpy. Apart from this, temperature, concentration and conditions, that is a constant pressure or constant volume, that will be also going to influence the reaction enthalpy. So we understand the reaction enthalpy, it is basically heat evolved or heat absorbed when the number of moles of reactant react completely with each other. At that time, we will call the reaction enthalpy. Now we are going to discuss another very important enthalpy, reaction. Now combustion enthalpy. It is denoted by delta Hc, and when it is in a standard form, that is standard enthalpy of combustion. What is defined? What is the definition of this combustion enthalpy? It is the heat evolved. The combustion enthalpy, it is the heat evolved when 1 mole of substance completely burned or oxidized. This is called the combustion enthalpy, and when the reactant and product are in the standard state, standard state that we already discussed. It is called the standard enthalpy of combustion. Standard enthalpy of combustion, and it is written by this. So we understand what is combustion enthalpy and what is the standard combustion enthalpy. When the 1 mole of substance is completely burnt or oxidized, it is called the combustion enthalpy, and combustion enthalpy is always negative because there is a evolvement of the heat. Heat is evolved, so it will be always negative. But there is also exception. Exception is this: in this case, N2 plus O2 plus 2NO, at that time enthalpy change is positive due to some partial oxidation of this reaction. This type of phenomena observed, but by and large you will find combustion enthalpy always the negative enthalpy, the heat is evolved. Okay, now you take one numerical that will give you some idea which type of problems numericals may come. This is one very good question, good numerical that we see. A cylinder of a gas contains 11.6 kilo of butane. If a normal family needs 2 into 10 to the power 4 kilojoule of the energy per day for cooking, how long will the cylinder last? Given the enthalpy of combustion is minus 2600 kilojoule per mole, and option is given 26, 39, 28 and 40. So what will be the answer of this? How do we solve? From the already we discussed about the combustion, enthalpy of the combustion. Enthalpy of combustion, it is given for the butane is this, and from this you have to calculate. First, combustion means what? Now 1 mole of substance, how much energy it will release. So we have to convert this 11.6 kilo butane into the 1 mole. So butane, we know 1 mole will have means 1 mole means 58 gram. Okay, so number of moles of butane, is how much it is? 11.6 kilo into 10 to the power 3 gram divided by 58. This moles of butane you have in a gas cylinder. Now it has been given that enthalpy of combustion means 1 mole of this substance will produce this amount of heat. So this number of moles, how much heat will be produced? That is a very simple thing. So we can write amount of heat produced how much? You simply 11.6 into 10 to the power 3 divided by 58 into 2600. Okay, per day you need this amount of energy. Today, days means we have to, how much day will cover, days will be by this cylinder, that will be given by 11.6 into 3 divided by 58 and 2600, and it is giving this 4. You have to divide this and it will coming around 26. You will calculate, you will find this will be 26 and the answer will be this. So this type of numericals will come. Okay. Next we are going to discuss another enthalpy, that is enthalpy of formation. It is represented by delta HF, and when it is in the standard condition we will put this O. Okay. So how do we define this enthalpy of formation? It is defined so enthalpy of formation, it is defined as the amount of the heat evolved or heat absorbed to produce 1 mole of the compound from its respective element. This is called the enthalpy formation, and when this compound and as well as the element are in the standard state, we will call this will be standard enthalpy of formation, and that is represented by this. Okay. Now what do we mean by standard state? That we have already discussed. Standard state means if the pressure will be 1 bar, temperature will be room temperature, that is 25 degrees Celsius to 98 Kelvin, and physical state of the element will be at the standardized state, which is the normal state, in which state it will present. As for example, suppose oxygen. When we talking about the oxygen normally present in the gaseous state. When we talking about the bromine, it is in the liquid state, right? When we talking about the iodine, it is in the solid state. When we are talking about the carbon, we will take the graphite as a standard. Graphite state as the standard, not the diamond. And standard enthalpy of formation of this element, by convention, it has been taken as 0. Standard formation of this elementary element, that is oxygen, bromine, iodine or carbon, in the carbon means in the graphite, not diamond. Diamond will not going to take it. Okay. So this will have the enthalpy of formation. Enthalpy of formation will be 0. That is standard enthalpy of formation is 0. During calculation, we have to take its value as 0. Okay. Now we take another enthalpy, that is the enthalpy of neutralization. What is that? This is again when we are talking about the enthalpy, either it is heat evolved or heat absorbed. In this case, neutralization, it will be the amount of heat absorbed, by 1 gram equivalent of acid to completely neutralized by the base, neutralized by base, or amount of the heat that is evolved when 1 gram equivalent of base is neutralized by the acid. We call it the enthalpy of neutralizations. Enthalpy of neutralization for the strong acid and strong base, it is a fixed quantity, that is 57.1 kilojoule per mole, or if we convert in the kilocalorie, it will be 13.7 kilocalories per mole. So, but for enthalpy of neutralization for the strong acid and strong base, it is fixed, but for the weak acid, weak base, or both the acid base is weak, at that case the enthalpy of neutralization will be slightly less. Okay, why it is so? Because some of the energy required to dissociate the weak acid and the weak base. Now we take one very good question to understand this concept. Good question that we have given. Given the enthalpy of formation of H2O is this per mole, minus 68 kilocalorie per mole. The enthalpy of formation of the OH minus ion will be, this option is given here, that you have to solve this. For that, we have to see this H plus OH minus ion, it will produce the H2O. And enthalpy of reaction of this is 13.7 kilocalorie per mole. Okay, and this can be enthalpy of formation. From the enthalpy of formation, we can able to calculate the enthalpy of the reaction also. How? Now, this is the enthalpy of reaction product. When we know the enthalpy of formation of the products and enthalpy of formation of the reactants, and from this we can able to calculate the enthalpy of the reaction. How? Let's see. This is the enthalpy of formation of H2O. We can write minus enthalpy of reaction is equal to enthalpy of formation of H2O minus enthalpy of formation of H plus ion and enthalpy of formation of OH minus ion. Enthalpy of reaction, that is given here, 68 minus 68, and enthalpy of formation of this, enthalpy of formation of H2O, that is given 68. Enthalpy of reaction, that we know, 13.7. Enthalpy of reaction is 13.7, and enthalpy of formation is given here 68 minus enthalpy of formation of H plus ion, it is 0, plus from this enthalpy of formation of OH minus ion, you can easily able to calculate. It will be, if we calculate it, it will be coming around 54.3 kilocalorie per mole, and this will be the answer. You can see it. So you understand that how we different type of enthalpy, what is the definition, and different type of your numericals will come in your exams, that we will already discussed in detail. That is all for today's lecture. That is all for today's video, and next video we will discuss about the another very important enthalpy, that is lattice enthalpy and enthalpy of the solution. Okay, thank you very much.